Good morning, students. Before starting the topic, let me ask you one simple question. Let us imagine two boys are standing on a block of ice and they push each other. Immediately after pushing each other, they start moving in opposite direction. So my question is, who will decide how fast each boy will move? Was it the boys? No, it was nature. So we are going to learn a very important and unbreakable law of nature, that is law of conservation of momentum. After studying this law, we can explain why gun recoils in backward direction after firing, why a rocket moves upward, why collisions happens, and how explosion works. So let's start the topic with revising momentum. What is momentum? Momentum is defined as product of mass and velocity of an object. We can say that momentum that is symbol of the momentum is P. We use capital P as the momentum symbol and it is defined as product of mass and velocity of object. Mathematically we can write it as P equals to mv. P equals to mv. In real life significance, we can say that momentum is something that makes it hard for a moving object to stop. Let me consider an example for you to understand it in better way. Let's suppose if a truck is moving with a velocity of 2 meters per second, the velocity is very less, but the mass of the truck is very high. So because of that, its momentum is going to be very high and it will be very hard for us to stop such a moving truck with our bare hands. But in spite of truck, if there is a cycle moving towards us with the same velocity 2 meters per second, it will be very easier for us to stop it with our bare hands because the momentum of the cycle is very less. Velocity of both cycle and truck is same, but mass of the cycle is very less in comparison to the mass of the truck. So it is very easy for us to stop the cycle because the momentum is very less. So momentum depends on both mass and velocity. And also momentum is a vector quantity. Which quantities are known as vector quantities? The quantities which have both magnitude as well as direction are known as vector quantities. So our momentum have both magnitude as well as direction. So this is a vector quantity. So if a ball is moving in positive x direction, ball of mass m is moving in a positive x direction with u1 velocity, and another ball of mass m moving in negative x direction, this I cap shows positive direction and minus I cap shows negative direction, then both the balls have same magnitude of momentum, that is, let's say this P is equal to m u1 and this P is equal to m u1, but this momentum is in the positive x direction, so we will write I cap in front of it, and this momentum is in the negative direction, so we will write it minus I cap in the negative direction. We can say that magnitude of both the momentums is same, but direction is different. That is why both the momentums are different and they are not considered as same. Because it is a vector quantity, so to be the same, it should have magnitude as well as same direction. So momentum is a vector quantity. Okay, now let us move to our real topic, that is law of conservation of momentum. Before that, let me rub it. So our topic is law of conservation of linear momentum. Law of conservation of linear momentum. This law states that if on a system there is no external force acting, then the system will have a constant momentum. It does not matter internally what is happening in the system, but if the external force is zero, the system will have a constant momentum. We can write it as, it states that if there is no external force acting on the system, then its momentum will remain constant. Its momentum will remain constant. So let's understand it by an example. Let us consider two objects. First object with mass m1 and initial velocity u1. It is moving with initial velocity u1. There is another object mass m2 and it is also moving with some initial velocity u2. And suppose the u1 is greater than u2, then they will collide at some point. So after collision, let's have m1 have a final velocity v1 and m2 have a final velocity v2. Then according to our law, initial momentum of the system is mass 1 plus mass 2 and their velocities. So this is system. So our law says that initial momentum of the system, that is m1 u1 plus m2 u2, should be equals to the final momentum of the system, that is m1 v1 plus m2 v2. Please pay attention that in this example there is no external force acting on the system. That is, there is no external force acting on mass 1 or mass 2. So whatever they are doing it internally. If they are colliding with each other, they are jumping on each other, they are moving away from each other, they are moving towards each other, it does not matter. If we are considering both mass 1 and mass 2 as a system and there is no external force acting on it, then there will be no change in momentum. Momentum will remain conserved. So when the collision takes place, that is the internal matter. There is no external force acting on it. So we can say that it does not matter if they are colliding or not, but the momentum will remain conserved. So after the collision, momentum becomes m1 v1 plus m2 v2, but it should be equal to m1 u1 plus m2 u2, that is initial momentum. That is, this makes our pi and this makes our pf. I denotes initial and p denotes momentum. Initial momentum, final momentum. So let us now discuss from where this law of conservation of linear momentum is derived from. So this law is basically derived from third law of motion. Third law of motion given by Newton. Third law states that every action have equal and opposite reaction. That is what we have learned. If we explain it, we can say that it states that if body 1 applies some force on body 2, then same equal amount of force will be applied by body 2 on body 1. And these two forces are internal forces and they will ultimately cancel each other, and if you see, there is no external or no net force acting on the system. And because there is no net force acting on the system, the momentum of the system cannot be changed. Momentum of the system cannot be changed. And this is what makes our law of conservation of linear momentum. Let us consider a real life example of conservation of momentum. We all have seen some videos where someone fires a bullet and immediately after firing they feel a backward push from the gun. That is a jerk, we can say. We can say that gun and bullet both makes a system here, and both have zero velocity initially, so their momentum is also zero initially. So when the person pulls the trigger, the bullet comes out of the gun with an extraordinarily high velocity, which gives it a momentum in the positive x direction. So the bullet has some momentum when it is fired. Because at the starting the system has zero momentum, so gun should also have some momentum in opposite direction to the bullet, so that both can combine and nullify each other or cancel each other. I just want to say that if this is our bullet and moving in the forward direction with some momentum p, then our gun should also, this is our gun, this gun should also have some momentum p, negative p in the opposite direction, so that p plus p can become 0. So this is why our gun recoils backward when it is fired. Now same thing works in rocket. Now let us consider a numerical. Numerical goes that an object of mass m1 moving with velocity u1, we can take the values mass 2 kg and velocity 3 meter per second, and strikes another object of mass say 5 kg at rest. After collision, let velocity of mass 2 is 1 meter per second, then find velocity of mass 2 kg. This is our question. We can make it numerically as this is m1 2 kg moving with initial velocity u1 of 3 meter per second, and it strikes second mass m2 of 5 kg, which is at rest, u2 is 0. After collision m1 have a velocity v1, we don't know what it is, so we will write as v1, and m2 have a velocity of 1 meter per second. What we have to find is v1. So So the solution can be, we know that there is no external force acting on the system. M1 and M2 both makes the system, and there is no external force acting on the system. They are striking each other internally, so that is their internal matter. There is no external force, so the momentum will remain conserved. We can say that P initial will be equals to P final. So what is P initial? Momentum initial, that is M1 U1 plus में M2 U2, and it should be equal to M2 V1, sorry, M1, it should be equals to M1 V1 plus में M2 V2. And what is M1 U1? It is M1 is 2 kg, U1 is 3, 2 into 3 plus M2 is 5 and U2 is 0. M1 is 2 and V1 we have to find, plus M2 is 5 and V2 is 1. So what do we have here? 3 to the 6, and this will become 0, and 2V1 plus 5. So we will get this 5 on this side, and we have 2V1. So now V1 equals to 6 minus 5 is 1, equals to 2V1, and V1 will be equals to 1 by meter per second. So this will be our final answer. Let us stop here and revise the topic. We have studied that what is momentum? Momentum is mass into velocity of an object. And what is law of conservation of momentum? Law of conservation of momentum states that if there is no external force acting on an object or on the system, then its initial momentum will be equals to its final momentum, or we can say that its momentum will remain conserved, remain constant. And the third point, we have seen that this particular law can be applied to find why a gun recoils, how a rocket moves upward. In the next topic, we are going to learn about elastic and inelastic collisions, and we will move to higher or advanced numerical problems which are more frequently seen in IIT JEE exams. Thank you so much.